Hey guys, in this video I'm going to take a closer look at the Wavetek 148A that I just got off of eBay. Now, I know this has problems, or at least the seller says it has problems, so I'm assuming it has problems. And that would be that some of the controls don't respond, like I don't think you could vary the frequency, and the overload light is on, but they showed a photo of it hooked up to a scope and it was putting out a sine wave. Now, I also have a Wavetek 183 that looks fairly similar, and that was also a cheap eBay find, which also was not working, but all I had to do with that one was pop open the cover, reseat a connector cable, and a couple of the chips were working fine. So, we'll see what it takes with this. Now, I like the Waveteks because they're made out of discrete components. This is from about 1979. Things like the venerable 741 op amp and common transistors, and the service info readily available, first full schematics, parts list, service info, troubleshooting guide. So I think there's some hope for this. But first thing I want to do is pop it open before I even think about turning it on. Nifty little power thing on the back here. So it's a fuse, you pull this and the lever comes up, pops the fuse out for you. Normally it'd be slid over, you plug your power cord in there. Little power transformer back there. Alright, I want to get these Phillips screws off. Pop it open. Now, I'm sugarcoating things a little bit when I say the parts are readily available. I did a little research, particularly looked at the output that drives the 50 ohm coax, and it uses some transistors that could be pretty darn hard to replace. So I had a little excursion into the world of obscure vintage semiconductors, which seems to be filled with bogus parts out of Southeast Asia, especially for amplifiers. So yeah, there are websites that claim to have stocked like anything and everything when it comes to transistors, but they might be rebranded, remarked, bogus, I don't know. Then there are some supposedly reputable dealers that are charging a small fortune, like $30 for a transistor. And other guys that are selling generic, unmarked, or house number transistors that they claim are the right thing that are cheap. So, I don't know. You don't know who to believe. I guess you go with the cheapest option first, see if they work. If not, go from there. Alright, there is part of this bad boy. I can tell there's a second board underneath there already, so check that out. That is 1979 technology. Oh, actually, I think I see an 81 date code. Obviously, they made this for a few years. Good old Sprague orange drops, and there's 741 op amps. National Semiconductor. Got neat little labels on here, like it says current source sync right here, signal shaper, buffer. So in other words, they're labeling the various sections. I wasn't expecting the output amplifier to be over here, but apparently it is, which is, oh, because I got it upside down. Duh. So there's the output jack, so it makes sense. Yes, there's the amplifier. So some of these would be those hard to get transistors, in particular 215160, or sorry, 2N5160. So at least two of them in this guy. Curiously, it's the PNP 5160 that's hard to find. The NPN that goes with it in the push-pull output, that seems to be readily available and still made. A couple bucks at like Mauser, so go figure. Ta-da. Alright, this is what I really wanted to see, was power supply, see if there were any bulging caps. Doesn't look like it. Well, hard to see the two boards, or at least what's in between them. Kind of an aluminum plate ground shield between them, but there are no parts in between the boards. So it looks like this, I call it modulation control. Okay, alright, cool. So, interesting thing about this function generator is that there's actually two function generators in here. On this board, in this corner, there's an Intersil 8038, which is a single chip function generator solution. So this chip right here, hook up a few external components and you got yourself sine, square, and triangle waves out. So this part is a mini function generator just used for modulation. So if you look on this front control panel, this stuff is like my Wavetek 183. It's like just a plain old function generator. Pick your waveform, your frequency, your output levels, and then this is another function generator. You pick your waveform, pick your frequency, and this is used for modulation. So a lot of generators will just have like a 1 kilohertz sine wave internal modulation, and that's it. You can't change the frequency, you can't change the waveform, you can't change modulation percentage. This you can do all kinds of fun stuff. So and you can see you can do a sawtooth here too. So if nothing else, you dial this into your favorite AM frequency, hook up a random length of wire to this, choose your modulation of choice, and you can hear it on your radio. So these can definitely be used to test and align AM and FM radios, because you can also sweep 10.7 megahertz if you want to do like the S-curve on a scope. However, it's not really intended to be a sweep generator, so it doesn't have markers or anything like that. It doesn't have precise frequencies, so you'd have to use a function generator. A frequency counter in conjunction with this function generator to get the precise frequency, like 455 kilohertz for an AM radio IF, for example. But you could use it. Be curious to see how stable this is, assuming I can get it to work. Alright, so I don't see anything obviously wrong with this, so I'm going to slip it back into the cabinet and try to power it up. So here we go. Alright, turns on, over the light, just like the seller said. And it does put out a waveform. Got a bunch of spurious spikes on it, but sine wave. And let's see, yeah, and just like they said, does not respond. Changing the level, it gets rid of the noise. It's probably a very dirty variable output control. And, okay, I can change. What kind of mode is this thing in? DC, let's get some AC coupling going. So there's a DC offset, so when I change the amplitude, it's shooting off the... Alright, so it seems like the output attenuator core switch is working. Just very, very dirty, I think. But the variable output level control is not doing anything. Curious that the stepped switch works. But not the variable part. Where's a DC offset coming from? DC offset's on 0, and adjusting it does nothing. Well, okay, it's doing a little bit. It's wiggling up and down. So it changes DC offset. The waveform should be moving way up and way down. Mode doesn't do jack. Symmetry doesn't do anything. Frequency range doesn't do anything. And none of this stuff does anything. Oh, this kind of does something. It looks like it's actually so external trigger continuous. Internal trigger, internal gate. Almost looks like it's a little bit of frequency modulation or something going on. Or amplitude modulation. Anyways, let's see what frequency we at. Whoa! That is 114 megahertz. How is that even possible? At like 6 volts peak to peak? That seems to me like the only way that could... Well, I wouldn't think that these output transistors were capable of doing something like that. Huh. Yeah, I'm on the 5 nanosecond per division scale. Wow. So what I'm thinking is the output amplifier is just going into crazy oscillations. The FT parameter on those output transistors is about 300 megahertz. So yeah, they're capable of doing really high frequencies, but I wouldn't have thought they could do that high a frequency at this kind of amplitude. Whoa. And they just disappeared and the overload light went off. So I wouldn't be surprised if those things are roasting inside there. I'll pop this off and see how toasty things have gotten. Actually, not very. This thing's just barely warm. Barely any heat coming off of these guys. Just feeling around other components. I don't smell any burning smell or anything. I don't see anything that's... Alright, so, yeah, this thing is even... well, it's exactly what the seller said. It produces a sine wave, none of the controls do anything, overload lights on. So, no deceptive practice on their part. Alright, so now troubleshooting fun begins. I think I will start with the power supply. Hang on, before I go tearing into this thing. Remember I said there's really 2 function generators in one? They do expose the internal modulation. Function generator, they give you that output, high impedance 600 ohm output. So let's see if this part is working. Hey, now that looks promising. Yep, I'm on the square wave function. And hey, I can change the frequency. Awesome. So what that actually tells me right away is power supply is good. Alright, how about triangle wave? Alright, nice clean triangle wave. And a sine wave. The way this thing works is it's a we'll call it a monostable, astable multivibrator. Anyways, it's a classic circuit that will produce square and triangle. That's what's in the heart of that Intercell 8038. And they take the triangle and they use some wave shaping tricks with, I believe, a diode network and turn the triangle into a sine wave. And there are some trimmers to adjust for the shape of it. So you see like there's kind of a little peak there. That's a residual bit of the triangle waveform coming through. Anyway, that's just used for modulation and for sleep. Yep. And there is the sawtooth. Cool. So if nothing else, I got myself a little basic mini function generator while the main thing is shot. And then the overload light has not come back on, so whatever vestige of life was left in the main function generator may have just died during my power-up test. So, it seems like the power supply is good in this thing. It's partially functioning, or at least the one board is. There are a couple voltage regulators on that main board, so I definitely need to check the power supply on the board itself. But what may be happening is that maybe everything's fine on that board, just the output amplifier is fried, because I've seen other people posting that have this or similar Wavetek generators, and the output amps are fried. Hence, trying to find those expensive, obscure transistors to fix it. But what I'll try to do is figure out where is the input to that output amplifier module and see if there's a signal going to it. I went through the user manual troubleshooting section and found a page for when the main generator has no function output. Step 1, it says to set all the controls in their initial positions, which are described here. And then I'm supposed to check test point 3 for a 2 kilohertz triangle waveform. So that's what I was suspecting, that if the output amp is fried, there are points in here where you can pick off the oscillator if it's working right. So I was going to find test point 3. There's test point 1. There it is, test point 3. So, scope, probe. I'm going to assume that the faceplate is grounded. And let's see. Look that on there. And I see something. Hey, we got a triangle wave and 500 millivolts, which means yeah, it's pretty close. Frequency. Oh, 1.95 kilohertz. I'll call that 2 kilohertz. And voltage is about 2.7 or so. So plus minus 1.25. It's off a little bit. I got plus minus. No, actually, that is on. It's 500 millivolts per division. We got half a volt, 1 volt, 1.25. All right. We're close enough. If good, proceed to table 6.4. Well, I just need to print out more, but at least I can do this step 2. So that's good. That means I guess I can skip over all this stuff. Check test point 7 for function waveforms at 2 volt peak amplitude from ground. Alright, so test point 7. Test point 4, test point 9. I referred back to the service manual, and it seems there's a good reason why I can't find test point number 7. It's because there isn't one. Because the easily obtainable comprehensive service manual is for a Wavetek 148, not a 148A. The only thing I could find for a 148A for free download was the instructions on how to use it. Not the service info. That I'm going to have to buy, it looks like. And comparing the two more closely, there are some considerable differences. This one seems to have a lot more stuff going on over in this area. For example, the 148 doesn't seem to have either one of these integrated circuits in it. But maybe I can poke around a little bit. So it's labeled here preamp, and then this is the amp. So there seems to be a signal being generated over here. I want to know if it's coming through over here. Well, it seems like one simple thing to check is this, which is the output level control. So I would think that one side's grounded, one side has a signal, and then the center wiper is the what gets fed into the amp. So So let me get my probe down in there. It's a little tight. There we go. And let's see. Oops, if I turn this thing on. There's something there. Alright, we got a sine wave. Huh. Let's see, I'm going to turn the frequency control. And hey, how about that? So, maybe it's just the output amp that has a problem. Let's see, I'll try changing various modes. There's sine, triangle, and square. Cool. And yeah, if I turn that knob, the output level changes. Output attenuator range switch doesn't do anything though. That probably comes later down the chain. Just going through the various ranges here. So yeah, that looks promising. Let's see, what else can we probe here? Let's see. Test point there. Test point 8. It's in there with the amplifiers, so let's see what that can do. Yeah. Try it from the side. Go. Oh, much bigger signal here. Okay, wow, it's okay, that responds with the varying control, but that output is almost 20 volts peak to peak. That must be the maximum output level this thing can do. So 5 volts, 5, 10, 15, probably 17 and a half or so, plus minus. It varies with the attenuator, but not with the range. So that to me looks like it's the output of the output amplifier, because that's a significant output level, and perhaps the attenuator comes after the amplifier. In other words, the amplifier might always be at fixed gain, and then the attenuator switches in some resistor dividers after the fact. So everything seems to be fine up to this point, so all that's left is this. Could it be a dirty switch? A bad coax connection? I just hooked up output cable with an attenuator on the end, 75 ohm, so I typically use when I'm working on TVs, and I hooked my scope up to that, and what do you know? This thing seems to be working fine now. So here are the attenuator coarse ranges and the fine control. So I have no explanation. This thing seems to be working just fine now. I don't know. All I can figure is that for me, opening this up and moving things around, something that was loose is now making solid contact. Maybe some capacitors needed to reform, so this thing just had to be left running for a while. Maybe it's a problem that's going to resurface at any moment. I don't know. Well, the overload light is off, so if I go to the highest output range and turn the output all the way up, it doesn't come on. But remember, it only comes on with a 50 ohm load when you reach some certain threshold. So let's try clipping on a heavier load and see if that trips. Here's a 33 ohm resistor. I'm going to throw that on the output. And now turn the level up. Still no overload though. So maybe it's not working 100% right. But I still have output. So that's a good thing. Oh, that's curious. I just switched from triangle to sine. Maybe the overload indicator only works right when you're in sine mode? Let's square. That comes on in square mode. Not triangle. That's weird. Well, if that's the only minor thing that's a little bit funky with this, I can live with that. I don't plan on driving heavy loads at full output amplitude anyways. So cool. I thought I'd have to break out the soldering iron at least to do a little bit of work, but hey, I'm not complaining. So I think I'll put the case back together, flip this thing over, and put it through its paces and make sure the other functions are working right. I moved it up here on top of my scope, so hopefully you guys can follow along with what I'm doing. So, I am in just plain old sine wave output mode. So, turn this knob, the frequency changes. Turn this knob, output level changes. Pretty basic. And then this is your function, so sine wave, triangle wave, square wave. And these, I believe, are pulses, and you can adjust this pulse width, yeah. So, this does the negative pulses, and this should do the other way around. Yeah. Okay, cool. You can also mess with symmetry on these waveforms too, the triangle and the sine, but so you basically make a sawtooth or a funky looking messed up sine wave. But that gives you some idea how they make the sine wave. It's unlike an RF generator, which is designed to produce really clean sine waves and typically nothing else. This is made to produce a variety of different types of waveforms. So there's a wave shaping circuit in there, so they basically take the triangle wave and feed it through a wave shaping network to turn it into a sine wave. And when I mess with the symmetry, I think you can see that it really is just a triangle wave that's basically been filtered. So if you leave the symmetry in the calibrated off position, you get you get the cleanest sine wave possible. There are also some trimmer controls inside to tweak that. If I ever do get my hands on the service and calibration instructions, I'll go through this. There's probably like 20 or more trimmers inside that I should probably be tweaking. Okay, so that's your basic function generator options. Now, what about all of this stuff? Well, let's put on some basic Am modulation. Alright, looks kind of funky. And hey, there we go, Am modulation. Just increase the carrier a bit, so that's more typically what you'd see is very high frequency carrier, lower frequency modulation. And let's see, the inner control here controls the modulation amplitude, so as I vary that, vary the amount of modulation, so no modulation, more and more and more, until I actually overmodulate and it's starting to cross over itself there. Now another connection on my scope is going to the sync out. I'll leave that off for now. I think I know what that does, but I'm not 100% sure just yet. Alright, so that's AM, seems to be working fine. Oh, and one nice thing is, so I'm just doing a sine wave modulation, so I can change the amplitude percentage, I can change the, the modulation percentage, I can change the modulation frequency too. It'll be a little tough to trigger on this stuff when you get to these complex waveforms. There we go. And you can modulate it with triangle wave, or square wave, or sawtooth. Now what about FM? Okay, I think it's freaking out because got my sweep percentage way too high. It's kind of hard to see, but I think I'm sweeping it. My modulation is going like from DC through a huge range of frequencies, so I'll just cut down that modulation percentage. And there we go. I'm gonna increase the modulation. And there we go. Basic FM. So it's changing the frequency low to high. Increasing the modulation. Back, and you can change modulation frequency. Go really slow, so it's like compressing and stretching out a spring. And now phase. That's where I'm hoping this sync out will help, because phase modulation, fixed frequency that changes phase with relationship to a reference. Without a reference, you would see nothing. That relates to TVs, actually. So, black and white TV, AM modulation for the video, FM modulation for the audio. Then came along color TV. Well, they didn't want to break all the existing black and white receivers, so how can you support both a black and white TV and a color TV? Phase modulation. So they stuck with AM for the video, also referred to as luminance, in other words the brightness level that you see on the screen. They kept FM for audio, and they stuck the chrominance or color info in phase modulation. But again, you need that reference, otherwise it's meaningless, because it's a phase shift with relation to what? You need a reference oscillator. That's what the color burst is for. So on a color set, you get a 3.58 megahertz local oscillator, and each blanking interval, each sync pulse as the screen goes from left to right and back around again, they sneak in a little burst of a reference signal from the transmitter, and you phase lock your local oscillator to that, and that's your reference to compare to get your color info. So let's see what this does. As I suspected, you flip it on. So here's our FM modulation. Get a phase modulation, you see nothing. Even if I crank it up all the way. So what I'm hoping is that if I synchronize to the sync pulse and we do phase modulation, that this will shift back and forth a little, but I'm not sure about that. Also not sure how to choose my sync source on this scope. Source, or trigger I should say, trigger source 1. Still not doing anything. So it's possible it's not working. Or this sync out, I think actually what probably is happening is a sync out is always just corresponding to like the peak on your output signal. However, if they don't provide some sort of reference out, then how are you supposed to do anything with phase modulation? External trigger in, external mod in, FM in, modulation generator out. Well, let's take a look at that. Okay, yes. If we bring up the modulation generator and sync on that, then we can start to see some of this phase modulation action. So now I've got the phase modulation cranked up all the way, and we're starting to get like Lissajous patterns you see in a scope when you check for phase relationships. Sine on that. So yeah, this definitely seems to be working. Just be nice if these were, if we get this thing to sync a little bit better. So what's basically happening is it's staying in one phase here, then it jumps up and it's shifting to another phase during that period. That's why you get a discontinuity right here. You kind of see how it goes wobbly as it passes through that point. Probably not the best explanation of what phase modulation is, so I encourage you to do a little web research on your own if you'd like to see more about how it actually works. But the point is, this thing seems to be fully functional, so it was well worth the gamble. Now, one last thing I want to do is see if my radio can pick it up. So I took the output and just kind of put it in the general vicinity of my radio over there. And let's flip to Am Modulation. And let's see, going to the 1 megahertz range. Got my radio tuned around 1350. There it is. Yeah, more like 1400. Just crank the level out. Alright, so there is my modulation. Turn it all the way down. Don't hear anything. Crank it up. Change frequency. So, excellent. I'm kind of curious about this too. I think you can actually combine modulation modes on this if you were so inclined. Here's one last feature. External modulation, so you can feed in an external signal, MP3 player, another signal generator, or whatever, to modulate this. So I happen to have another Wavetek. It's my 183, so I'm taking the output of this. External mod in, Am Modulation external. So if I turn this up, this is my modulation source, which is way too high a level. There we are. So, hope you enjoyed this look at a Wavetek 148A. There's a few of these on eBay that pop up on a semi-regular basis. If you want to take a gamble, I've seen some other ones on there that are not working, fairly inexpensive. Now that you've seen what's inside of one of them, if you feel up to the challenge, you can try repairing it yourself.